All right, welcome back. I'm Thomas Paul, over 10 years tutoring math and science and unlocking student potential. Back for another trig trick. And looking at here, we have a triangle, and it says in the figure above, segment BD is parallel to segment AE. What is the length of CE? Okay, so we start again with our background steps of how to take apart this next trig trick. So look at the first thing to notice is I recommend when you have these double triangles, triangle within a triangle, draw them separately. So draw triangles separately. So I'll do that first one here. Let's draw just a big one here. Or if you don't have time of the test, you can just draw right on these, and just redraw the small one here. There's our small one, 6 there. And this is going to be E, A, C, and this is going to be D, B, C. And we know, of course, these are going to be similar because that angle is the same. And because these lines are parallel, these two, if this angle is right, this angle too must be right because they're corresponding angles. So these are similar triangles by AA. You can prove that really quickly. That brings us to the next step. If we switch colors here, let's go to green. 2, we need to be able to make our ratios for similar triangles. So here, let's make our ratio, and let's notice what we're looking for here. We're looking for the length of segment CE, this segment here. So let's give it a familiar letter. Let's call it X, just X. I like that letter. And I get one more value here, that's an 8 there. So let's start with a ratio. Because X are unknown, or segment CE is on the big triangle, we're going to do our ratio big triangle over small triangle, because that's going to help me to get X on top. So let's first deal with this one. Well, our big triangle length is 18. Our small triangle length is 6. So now we've established a 3-to-1 ratio. If we break this down, you can do that first, it makes it easier. And now we need to compare the value of X. X is the hypotenuse. Oh no, we have this value of X here. We don't have it here, but it's a right triangle. So this hypotenuse value is going to be the square root of 8 squared plus 6 squared. And we know that 8 squared is 64. We know that 6 squared is 36. So it's going to be the square root of 100. And we know that that's going to be 10 here. Okay, so and there we go really quickly. We now have this equation to take a look at. To solve for X, we multiply both sides by 10. And so we get that X equals 30. This is, then of course, X we just said was the same thing as segment CE. So to solve a problem like this, we immediately want to recognize they're similar triangles, and that's because a triangle within a triangle is inherently similar, as long as these lines are parallel, of course. And then we could find the length of CE by making our ratios. We had to use Pythagorean theorem, but that didn't slow us down because we had 2 right triangles if you saw that these were corresponding angles. For Science Math Magic Tutoring, until next time.